This is MA 104, Section 4.3, numbers 55, 57, and 50. We're asked to write this polynomial as a product of linear factors. To do that, we first need to come up with possible rational zeros. And to do that, I first look at the constant term, which is negative 4, and find factors of negative 4, which would be plus or minus 1, plus or minus 2, and plus or minus 4. I then need factors of the leading coefficient, which is 6. So factors of 6 would give me plus or minus 1, 2, 3, and 6. My possible rational zeros then, which I need in order to be able to get those factors, but my possible rational zeros would be all numbers that are combinations of the factors of negative 4 in the numerator and the factors of 6 in the denominator. So that would give me plus or minus 1 over 1, which is 1, plus or minus 1 over 2, which is 1/2, plus or minus 1/3, and plus or minus 1/6. Those are all the possible numbers that have 1 in the numerator. Then I move on to 2. I need 2 over 1, 2 over 2, 2 over 3, and 2 over 6. So plus or minus 2 over 1 gives me plus or minus 2. Plus or minus 2 over 2 simplifies to 1, which I already have, so I don't need to repeat that. I'll move on to plus or minus 2/3. Then I have plus or minus 2 over 6, which is just 1/3, and again I already have that. Moving on to the 4, I'll do 4 over 1, so that's plus or minus 4. Plus or minus 4 over 2 simplifies to be 2, which I already have. So I'll take plus or minus 4/3. And then plus or minus 4 over 6 would simplify to be 2/3, which I already have. So this is my complete list of possible rational zeros. To find the numbers that actually are zeros, and again, please keep in mind, this is a third degree polynomial, so I'm looking for 3 factors. I have a 6x to the third, I have a 13x squared, I'm missing x to the first, so I'll need to put a 0 in for that, and then I have the negative 4. So I place those numbers along the top of my synthetic division, 6, 13, 0, and negative 4. Just separate that there, and then I start testing my possible rational zeros. I'll start with positive 1. Bring down the 6. 1 times 6 is 6, plus 13 is 19. 1 times 19 is 19, plus 0 is 19. And 1 times 19 is 19, plus negative 4 is 15, which is not 0, so I move on. I'll try negative 1. Bring down the 6. Negative 1 times 6 is negative 6, plus 13 is 7. Negative 1 times 7 is negative 7, plus 0 is negative 7. Negative 1 times negative 7 is positive 7, plus 4 is 3. I'm sorry, 7 plus negative 4 is 3, but either way that's not 0. Moving ahead, let's try negative 2. Ordinarily we would try all of those possible zeros in between, but let's skip ahead and try negative 2. If I bring down the 6, negative 2 times 6 is negative 12, plus 13 is positive 1. Negative 2 times 1 is negative 2, plus 0 is negative 2. Negative 2 times negative 2 is positive 4, plus negative 4 is 0. So this is the polynomial, or this is the possible zero rather, that I want, which means that if I start to write my polynomial p of x as a product of linear factors, I could say that p of x is equal to, since negative 2 is a 0, x minus a negative 2, or x plus 2 is a factor, times the quotient is the other factor, so that would be times 6x squared plus x minus 2. So I'm breaking that polynomial down a bit, and I have one linear factor, but I need to keep going to get other linear factors. So I need to be able to write the 6x squared plus x minus 2 as a product of linear factors. A lot of times your quickest way to do that is to use the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And again, we can identify the 6 as a. The 1 that's understood to be with the x is my b. And then the negative 2 is c. If I apply the formula using these numbers, I get x equals b is 1, so the opposite of that is negative 1, plus or minus the square root of b squared, so 1 squared is just 1, minus 4 times a times c, so minus 4 times 6 is 24, times 2 is 48, so minus a negative 48 is the same as plus 48. All over 2 times a, so that's all over 2 times 6, which is 12. If I simplify this a bit more, I get x equals negative 1, plus or minus the square root of 1 plus 48 is the square root of 49, all over 12. So I have x equals negative 1 plus or minus the square root of 49 is just 7, all over 12. Negative 1 plus 7 is 6, divided by 12 is 1/2. So the first 0 that we can get from the quadratic formula is x equals 1/2. The second one is what I get when I take negative 1 minus 7, which is negative 8 over 12, and that simplifies to negative 8/12, which is negative 2/3. Since these two numbers are zeros, that means x minus these numbers are factors. And again, the whole point of the problem was to write p of x as a product of linear factors. So doing so, I have p of x equals, my first linear factor was x plus 2. My second linear factor will be from taking x minus 1/2. And the third and final linear factor, since negative 2/3 is that 0, then x minus a negative 2/3 or x plus 2/3 is my final factor. In this problem, I'm also asked to write the polynomial as a product of linear factors. Again, the way to start is to find factors of the constant, which in this case is negative 4. So my factors of negative 4 would be plus or minus 1, plus or minus 2, and plus or minus 4. Then I need factors of the linear coefficient, or I'm sorry, factors of the leading coefficient, I should say, which, since that's understood to be a 1x to the third, I need factors of 1, which are just plus or minus 1. My possible rational zeros, then, come from taking every combination of number that has the factors of negative 4 in the numerator and the factors of 1 in the denominator. And again, since all of those numbers would just be over 1, the factors of negative 4 are my possible rational zeros. To find out which of those numbers actually end up being my zeros, I set up the synthetic division. If I look at my polynomial, all of my powers of x are represented. They're all in descending order. So I can just list the coefficients. 1x to the third, 2x to the second, negative 9x to the first, and then the constant, which is negative 4. If I start testing those numbers, I can start with the 1, bring down the 1. 1 times 1 is 1, plus 2 is 3. 1 times 3 is 3, plus negative 9 is negative 6. 1 times negative 6 is negative 6, plus negative 4 is negative 10, which is not 0, so I'll move on to negative 1. Bring down the 1. Negative 1 times 1 is negative 1, plus 2 is 1. Negative 1 times 1 is negative 1, plus negative 9 is negative 10. Negative 1 times negative 10 is positive 10 plus negative 4 is 6. Also not 0, so I need to move on. We'll skip ahead, we'll skip the 2's, and we'll try negative 4. Bring down the 1. Negative 4 times 1 is negative 4, plus 2 is negative 2. Negative 4 times negative 2 is positive 8, plus negative 9 is negative 1. Negative 4 times negative 1 is positive 4, plus negative 4 is 0. Negative 4 ends up being my rational 0. So since negative 4 is a 0, x minus a negative 4, or x plus 4, is a factor. So I can start by writing p of x as x plus 4 times, these will be the coefficients of my quotient, so those are the coefficients of the other factor. That would be x squared minus 2x minus 1. I'm asked to write as a product of linear factors. This is a linear factor and a quadratic, so I still need to work with the quadratic. I still need to break that down. And again, the quickest way to break that down is probably the quadratic formula, which is x equals the opposite of b, plus or minus the square root of b squared, minus 4ac all over 2a. b in this case is negative 2, the opposite of that is positive 2, plus or minus the square root of b squared, negative 2 squared is 4, minus 4 times a times c. So minus 4 times 1 times negative 1 actually ends up giving me plus 4. All over 2 times a, so that's all over 2 times 1, which is 2. So x is equal to 2, plus or minus the square root of 8 over 2. The square root of 8 is just 2 square roots of 2, so x is equal to 2, plus or minus 2 square roots of 2, all over 2. Every one of these terms can be divided by 2. So x is equal to 1, plus or minus the square root of 2. So that means that my remaining two zeros are 1 plus the square root of 2 and 1 minus the square root of 2. Okay, so these numbers, even though there's more than one term to it, these numbers represent my zeros. Negative 4 was that third zero. To finish this off by writing p of x as a product of linear factors then, remember that to get a factor I just take x minus a 0. Well, like we had talked about, if negative 4 was a 0, then x minus a negative 4, or x plus 4, is a factor. If 1 plus the square root of 2 is a 0, then x minus 1 plus the square root of 2 is a factor. And finally, if 1 minus the square root of 2 is a 0, then x minus 1 minus the square root of 2 is a factor. I have 3 linear factors. Even though there's more than one term in some of these zeros, this is still written as a product of linear factors.